Now, fx is differentiable for all x. f1 is equal to minus 2, f dash x is greater than or equal to 2. In the closed interval 1, 6, the range of values of f of x. Now, we'll apply Lagrange's mean value theorem. What it says, f dash c is equal to f of b minus f of a by b minus a. So, we know the interval 1, 6. So it clearly implies that this is a comma b. So f of 6 minus f of 1 by 6 minus 1 is equal to f dash c. So f of 6 minus plus 2, because f of 1 equal to minus 2 is given to us, divided by 5 is equal to f dash c. So they gave as f dash x is greater than or equal to 2. So we can say f of 6 plus 2 by 5 is greater than or equal to 2. Or f of 6 is greater than or equal to 10 minus 2, or f of 6 must be greater than or equal to 8. So this can be written as closed interval 8, infinity. Closed at 8 and open at infinity. We can see the option A is correct. I repeat once again, fx is differentiable for all x. f1 is minus 2. f dash x is greater than or equal to 2. They gave any value lying between 1 and 6. Hence the range of value of f of x. Lagrange's mean value theorem says that function is continuous in closed interval, differentiable by open interval, then there exists a c lies between a and b such that f dash c equal to fb minus fa by b minus a. F of a is given as f of 1, which is equal to minus 2. F of b is say f of 6. So f of 6 minus f of 1 minus 6 minus 1 is equal to f dash c. f6 plus 2 by 5 is equal to f dash c, or f6 plus 2 by 5 is greater than or equal to 2, or f6 is greater than or equal to 8. So therefore, the range of f6 is from 8 to